Okay, so we're on section 1.16 on page 137. So go ahead and try problem number A. And we're just trying to find a bunch of different rectangles that have a area of 48 square inches. So think about what area is and try to draw as many as you can think of. And they have to be whole numbers, so we're not going to mess with decimals. So like 1.5 by something, we're not going to worry about that. So see how many you can have. Okay, so area is the space inside. So for example, if I have a pen here. So like a square that's 3 by 3 would have an area of 9 square inches or square feet or whatever. So I want to get 48. So I could have a really long, skinny rectangle that's like 1 inch by 48 inches, and that would give me an area of 48. So I could have 1 by 48. I could do 2 by say 24, because 2 times 24, and again if I drew in all the little squares or whatever, so that would be 48. So 2 by 24 would work. 3, if I did 3, so I could have 3 inches this way by what, 3 by, what would that be, 16 this way, okay, and that would give me 48. And 4 by 12. 5 doesn't work because 5 times 10 is 50, 5 times 9, 45, so I'd need a decimal if I did 5. And then 6 times 8, so 6 by 8 would also give me an area of 48 square inches. So, and then I could, rotate them, I guess, and do 48 by 1, but it's really the same rectangle. So these are kind of all the way that I can find the area. And again, remember, area is the space inside. So if you have something that's 3 centimeters by 4 centimeters, you would have 12 square centimeters. You're creating a new unit here. All right, so go ahead and try problem B. Okay, so this time we're looking at perimeters. So again, if we think of that 3 by 3 square, if this is 3 centimeters, 3 centimeters, 3 centimeters, 3 centimeters, perimeter is like the distance around the outside, and so that would be 12 centimeters. And we're not creating a new unit, we're just measuring with strings, so it's still linear, and we're getting 12. So this time we want to have a perimeter of 48, and then it says find the area. All right, so kind of let's think of what we did before. We had a real skinny rectangle. But if this is 1 inch and 1 inch, that would use up, what, 2 inches of my 48, so I have, what, 46 left, and I have 2 sides. So if I divide that by 2, this would be, what, 23 inches and 23 inches. And so that, if I add up all the sides of my rectangle, that would add up to my 48, which is I want. So kind of with that same idea that we did before, let's try 2 inches. So if I have 2 inches here, 2 inches here, that uses up, what, 4? And so I have 44 left. Divide that by 2, and so that's going to be, what, 22? Okay, so then 22 inches and 22 inches. And again, if you add up all the sides. So pause the video and try to find the rest of them, and then count and see how many you come up with. Okay, so one thing to think about with math is to do a bunch of examples and try to do it organized, and then suddenly you might see a pattern. So as I start kind of doing these, I could draw 5 and 6 and 7 and 8 and 9 and 10 and 11 and 12 and so forth, 13, 14, whatever. But I notice a pattern that as I go up by 1 here, these tend to be going down by 1. So I'm thinking this is going to be 19 and 18 and 17 and 16 and 15 and 14 and then 13 and then 12. And then I could do 11, but notice that's going to be a repeat. So when I get to 12, 12, then I know I'm starting to go backwards and going to repeat these. So I can count these, and obviously I start with 1 and 12, so there's 12 total different ways of doing that. All right, why don't you flip the page and read the directions and then try finding the area of that triangle and trapezoid on problem number 2. Okay, so again, area is the space that it takes up, or the squares that it takes up. So on this first one, you can try to count the squares, so that doesn't look too bad. There's 1 square there, 2, 3 squares. Looks like these 2 halves would make another square, and then I have a half. So that would be 4 1/2 whatever, square units, square inches, square centimeters, whatever. So we'll just do square units. If you remember formulas, a triangle is half of a square or half of a rectangle. So some of you might have said, well, if I fill in the whole thing, it would be 9, and I just have half of it. So that's why the formula for a triangle is half base times height. So you could take the base and the height, which are at a right angle, which is 3 times 3, but then take half of it because you don't have the whole square. You only have half of it. So if you get the answer of 9 and take half of it, you could get 4.5. Again, square inches, square feet, square units, whatever they would be. All right, let's do the next one. So again, pause, try to count all the squares, see what you get, and then we will compare. Okay, so again, area, you're counting up space. So I'm counting my squares, and I think I got 12. But then I'm also looking for the ones that make other ones. So those halves make a whole, another whole, and another whole. So I can add 3 to that. So my answer is 15 square units. Now, there is a formula for trapezoids that's actually very similar to this. It's area equals half, but instead of one base, you have 2 of them. Because you have the thing that we call the base are the parallel sides. So this side up here is a base, which is 2, and this side down here is a base, which is 1, 2, 3, 5, 6, 7, 8, I believe. Okay. All right. So in this formula, it's half because, again, I don't know, if I double this, I get a parallelogram, which has the same formula as a square rectangle, which is base times height, but I only really have half of it. But my bases end up being 8, and then the 2 comes over here, the 8 here. So that's why we add them up. So I have a base of 8 and a base of 2, so that adds up to 10. And my height has to be straight up and down at a right angle, so right there, which is 1, 2, 3. And notice half of 30 will give me 15 square units. And I got that by counting as well. All right, go ahead and try problem number 3 and problem number 4. And again, remember, perimeter is when you go around the outside. Area is the space inside. Okay, so the perimeter is, again, when you count the distance around. So you have to be careful, like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. And it's just strings. So you're not counting squares. Your unit doesn't change. You're just adding up a bunch of things so your units stay the same. 51 is if you count the squares. So again, counting a lot of squares can be problematic. So you might want to maybe do this big rectangle first. And you could use multiplication to make that easier. So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So I pretty much know that's 35. And then I could, find how many are in these other areas as well. So I could be like, okay, well then there's, 2 in there. This is 2, 1, 2, 3, 4 is 8. And this is 2 by 3, which is 6. So then hopefully if I add those up, let's see, I get 35, 45, 51. So that's good. So you don't have to just count them. There are ways of doing that. Now, the next one, they have to tell you the slant because this is not a distance of 1. Like when you go sideways, it isn't a distance 1. So this is 5, 5, and this is 1, 2, 3, 4, 5, 6, 6, and then 1, 2, 3, 4, 5, 6 again. Is that right? So 18, and then 10 is 28. So again, remember, perimeter is the distance around. Now again, area, kind of the same idea. This is 6 by 6, so that's going to be 36 squares. I don't have to count them. This triangle might cause you a little bit of trouble because if you look, if I can erase some of my writing over here, the problem is you can try to make squares, but that's not quite a half, and this is more than a half, and you can't quite put them together like that. But what you can do is cut this in half, and then are you okay? You can move that triangle into this space to get a rectangle. So since these are identical, if I move it like a puzzle piece, then I get a nice full rectangle. So I get this space filled in. So then I can count the squares of this because that space fills in here. So if I do that, that would be what? 1, 2, 3, 4, 5, or sorry, 4 by 3, so that's 12. And I don't have to take half of it because I literally am putting this over there. And so I do have a full rectangle. So if I take 36 plus 12, I get my 48. Again, if you remember the formula for a triangle, you could also do that. So area of a triangle is half base times height. Half, the big base is going across, so 1, 2, 3, 4, 5, 6. And my height is straight up and down, so 1, 2, 3, 4. And again, the reason that works is it's kind of like you have a parallelogram again, and so you're doubling the area of this triangle, which you only really need half of it. So half of 24 is 12, which notice is the same answer when I made the box, so I can add those up. All right, the only other thing in this section is, as far as similar shapes go, if I can get down here, is that you can just scale things up or scale these down. So if things are similar, it means they're just shrunk or made bigger. So for example, like on this trapezoid here, if I rotate it, the 5, if I, on the little side here, if I double it, it lines up with the 10. So I can either take half of the 10 and get the 5, or double the 5 and get the 10. And then the 6 on the top base here, if I double it, I get the 12 inches on the top base here, or back and forth. And then the 24 on the bottom of the bigger trapezoid corresponds to the 12 on the other. So again, you can take half or double. So basically, the little trapezoid is half of all the numbers on the big trapezoid. And then the little trapezoid, if I want to go to the big one, I could just double everything, and that would give me the other one. So again, we say that's proportional because we're just scaling it up or scaling it down. So if two shapes are similar, you can scale up or scale down by multiplying by some type of multiplier or dividing by some type of multiplier. All right, there's no book homework on this section, so just do the online work and that's it.